3DEXPERIENCE CATIA is the backbone of our design process, and we use CATIA to manage all of our design files. This is also where we prepare all of our models for CFD analysis, maneuvering simulations, etc. These are the facilities of Sea Technology, pioneer in the maritime industry, and a testament to what can be achieved when engineers are given complex challenges to solve that requires lateral thinking, creativity, and the courage to develop new approaches. Since 2019, we have engineered new developments related to hull design, weight savings, and passenger comfort features. This new high-speed ferry is a result of a design project called Framtidens Hurtigbåt that Sea Technology has been a part of since May 2025. The aim of the project is to cut energy consumptions without sacrificing schedule reliability in real-world conditions. Our target is a 30% lower power consumption compared to a reference vessel. We aim to achieve this using a foil-supported trimaran with electric propulsion, designed and optimized for a set of predefined routes. Additional goals include a 40-knot top speed, operational profile up to HS 2.5 with defined speed envelopes per sea state. For us, designing a composite vessel was the obvious choice based on years of experience the group holds with production of composite tooling, vessels and parts. The design is based on a stiff, cost-effective GRP hull with good puncture resistance. We opted to use carbon fiber strategically to increase the stiffness in areas for foil supports, stiffness and other local reinforcements. Additionally, the superstructure and decks are all carbon fiber to keep the weight as low as possible. Beyond resistance and seakeeping, we prioritize maneuvering and stability tests, such as instrumented turning circles, 10-10 zigzag and ballast shift, to provide invaluable insight into the performance of the vessel. This has ultimately helped reduce the risk of the project. The design is ultimately resistance-driven, meaning every choice taken is based on reducing resistance and hence increasing fuel efficiency. However, stability, regulatory requirements and passenger comfort cannot be neglected. In our case, the dynamic stability requirements meant we had to accept a design with a slightly greater resistance to keep the vessel stable in its flying position and when performing high-speed turns in heavy sidewind conditions or the event of passenger crowding. The most surprising problem that arose during the initial testing was the stability challenges of the design. Initial consumptions regarding stability and foil placement had to be changed based on the results of early-stage CFD analysis. Also, the general arrangement of the vessel had to go through a series of iterations as more information from sub-suppliers and their systems were introduced, especially with regards to the initial assumptions regarding the size and placement of the battery system. 3DEXPERIENCE CATIA is the backbone of our design process, and we use CATIA to manage all of our design files. This is also where we prepare all of our models for CFD analysis, maneuvering simulations, etc. These models are also what's fed into our CNC machines to produce scale models for towing tank testing. The result is a continually evolving 3D model containing all information about the project, from geometry, system integration and supplier information. The partnership with PLM Group has helped us focus on the things we do best, designing boats, without having to spend time on troubleshooting or problem solving. Example, PLM Group helped us get the apps needed for us to render and export images for a turntable 3D model used on our website. They proved to be a good partner when it comes to informing us about available software and apps that may be of use to us.